Okay, so yeah, I just found it. So it's under container. So basically, we are using the container. So I was looking it in the flip fluid, but yeah, it's on the container. There's a collision here, and we just invert sign. So this invert sign inverts like your container. It turns it. So you see that the normals of the container is just facing outside. It's something like that. But just want them to do face inside, and just like the inside of the container becomes a geometry, like the collision object. So you see that it holds the fluids now. You see the fluids inside? It's just like they stay inside. But I want a lot of them. I don't want like just a little. So if I go to the flip solver, no, yeah. So if you just click on the flip fluid object here, this one, this little fluid object one. So particle separation is like 0.1, but I want a lot of particles, so I just press 0.0, like 2 or 3, I don't know. So you see like loads of particles are added now. If I play now, you see that it gets slower, but I start to see like some real proper fluid interaction. So we wait a bit, and we've got, you see that like we've got very nice fluid interaction inside. So some of these fluids might find a way to escape. So how to kill them? So you just click on the flip solver, you go to the particle motion, you say that so collision detection is move outside collision, and so if you turn that on, I'm gonna stop that. You see this kill unmovable particles. So anything that escapes out of, because this is not a properly modeled container, to be honest, but that would help. So you see that like we just say that whatever is outside just gets killed. So let's play it again. So those little particles that escape the simulation, they get killed by here that way. But you know that this is not you will end up seeing when it gets rendered, isn't it? You will see like proper solid liquids meshed, or as we say, so how I can view the same thing that I see, something that I see in the rendering here. So inside, I think it's fluid. Yeah, inside fluid, you see that. Okay, so let me explain the nodes that are added. The moment that we select our fluid object, which was this object, you see that it's hidden automatically. We selected that. We clicked on the particle fluids and flip fluid from the object. These three nodes are added. The first one is just generated all these particles, and the second one creates an interior for those particles to interact with, to work inside. And the third one, which is the most important one, is the tree or the network of dynamic operators. So they all work hand in hand to create that liquid simulation. So every time that you have a question or you want to change something you go and find through inside those nodes. So let's say I just want to change the display of this particle. I just get into like this fluid, flip fluid, and you see that a fluid is important, and then some processes has been applied on. But there's a surface preview here. You just click on that. Okay, sorry, not this one, surface preview, but this one, particle fluid surface. It's just a something that turns these particles into a mesh. It's basically an algorithm that just like connects them together. I'll just select this object. So like you see that those particles, so let's analyze one of them from. So those particles, they just get connected to create this surface. So, and then when I play, you see that this surface starts to show the behavior. If it's too slow, you can make a flipbook. Let's make a flipbook just in case to do it once. So I click on the flipbook. The setting opens. So it says reference frame start, which is 1, end, which is 50, or you can change it. Let's say from 1 to 50. Output file, we want to save it on my desktop. I call it test. Just let me make a folder, Houdini. Inside that, like the, so if you want it to be JPEG or something, flipbook. So it creates it says you that it will create 50 images, and okay, let's make a flipbook anyway. There are some stuff how to convert it automatically into like a move file inside here, but let's create a flipbook. This window will show up, and you see that the timeline just gets expanded, which is like basically it gets rendered. It renders them onto hard drive. So in that folder that we created, you see that on desktop, Houdini. So like, oh, okay, that's good. So it doesn't generate loads of images, image sequence. Okay, so let's play that now. Okay, so that was a quick overview of how Houdini works. Let me see if I have skipped any important. So we talked about like how this tree works. Okay, so let's go, and I just want to hide the container. I press W. So this is the fluid that we generated. I press spacebar F to bring it, frame it to this. So here there are 3 lighting settings. So I just want to add a grid here underneath that one. Press enter, move it up. So this is like a normal lighting, but sometimes you want, so this is like high quality lighting. So if you have light in the scene, and this is like lighting with shadow. if you have a light in the scene, so you go to the light and camera, and let's create a point light. And you see that this point light is just like working like here. Just move it here. So if you, every one of them is a one step higher quality. So here you see that like this is without, this is like, it gets a bit, so I just want to turn this off, a bit higher quality. And this one just like the lighting with the shadow. It's just viewing tools. So let me get rid of the light. What else? So there are some other stuff that we will talk about that later on. One thing that you might like is this, because many people like to have, I just want to delete this grid as well. Many people like to have their background black, especially those ones who create glowy, shiny particles inside Houdini, or work or want to see the outcome in with black background. Click on this eye, go to the background, and make it dark. So that's one very commonly used thing as well. What else? Okay, so every node that you click on, so this is also very important. So this is viewing, this is selectable, or when you get inside. Okay, let me get inside this one. Here we have, let's say, so different things like output, and then this is also very important, bypass. Sometimes you have added a node in the middle and you want to see if it works or not, what would happen. What if I turn off this point, this node for now to see what would happen? So you just bypass that node, and that node starts to function. So you see that static solver started to stop to function. So if you just turn it on again, it comes back. If you middle click on one specific node, so let's say I go here and I middle click on this box, it gives me a lot of very, very useful information. Those who work in Houdini, you see them keep middle clicking on nodes, because it gives them some very important information. Like sometimes some nodes, they have a red sign next to them. So let's say here I add a transform node. You see that it has a red, and I don't know what has happened. I middle click on that, it says, oh, not enough source specified. It means that it is not connected to anything. So I go and connect and provide sources. So middle click, don't forget that it's an information tool, or it's basically this eye middle click that we do. This eye information. Freeze. So you see this freeze node. Sometimes, so you see that every time that you play and you change anything, Houdini goes through. Let me hide this container. Houdini goes through the node tree from the very beginning to the very end. So it just does everything from the beginning to the end. So sometimes you are happy with whatever happens up to here, but you want to see what, so all of the changes that you're adding happens after something. So if you're happy with something, you can, so let's say if you're happy with whatever happens up to here, and you don't want the calculation to happen every time up to here, so just freeze that. So there will be no more calculation before this node, and all the calculations are added afterwards. So that's important as well. So what else? Okay, so these were some very basic principles of using Houdini. So next sessions we start to use Houdini for more complicated stuff, some very complicated simulations, or even like doing some procedural modeling. Okay, thank you.